Hey everyone, welcome back to the channel. This is part 13 of our SAP CAPM and Fiori full stack tutorial series. In this video, we will connect our CAP application to SAP S/4HANA Cloud and fetch live sales order data. Before writing any code, we first need to find the right sales order API from SAP's API Business Accelerator Hub. Open your browser, search for SAP API Hub. Log in with your SAP ID. If you don't have one, create it. It's free. In the search bar, type sales order. From the results, select the API named Sales Order A2X under the S/4HANA Cloud section. This API allows you to retrieve detailed information about sales orders, including order items, quantities, and units. This platform also provides a tryout option, which you can use to verify the fetched data. Once you open the API page, click on the API reference tab. Here, you will find base path, the available entities, and the metadata document, that is EDMX document. We will use this EDMX file to generate our OData client in the next step. Create a folder service specs inside a service folder in your code editor. Then drag and drop the downloaded EDMX file inside the newly created folder. Now let's install the SAP Cloud SDK generator to create the OData client for the API. Run the command npm install -d at sap-cloud-sdk/generator. This generator helps us automatically build the client code from the EDMX file, allowing our CAP backend to call the S/4HANA API easily. Then generate the OData client by running this command. You can copy this npx command from the description of this video. You can find a options-per-service.json got generated when you executed the Cloud SDK generator command. If it is not generated automatically, then you have to create this manually and then use the npx command. You will now see a new folder SRV generated API sales order SRV. It contains the ready to use JavaScript client for the sales order API. Next, create a cat-service.cds file in your SRV folder to define a custom function to fetch sales order data. Let's name the function as readInvoiceNumber, which takes a sales order ID as input and will later call the S/4HANA API to fetch details for that specific order. Don't forget to define the new function in the cat-service.cds file with the number of inputs and return type. After this video, I will push all my changes to my GitHub repository. You can pull the changes from there if necessary. Go back to the JS file and declare a variable to store the sales order ID. Import the API to this function. You can copy the API name from the service.js file inside the generated folder. For fetching the sales order items, we will be using sales order item API. Next, create a variable to store the authentication configuration for our API that point the SAP Business Accelerator Hub sandbox with your sandbox API key and sandbox URL. Every user have unique API key, but the URL will be same. You can find the sandbox URL under the configuration details tab. For this API key, log into the API Hub and click on Show API Key button. Then use SalesOrderItem.requestBuilder function. This helps us build OData queries in a simple and structured way without manually writing long OData URLs. GetAll means I want to fetch all records from the sales order item entity. Basically, I am telling the API, give me all the sales order items that match my criteria. Then comes the .select part. Here I am selecting only the fields I actually need: sales order number, sales order item, requested quantity, and the requested quantity unit. This is a best practice. Always select only the required field to make the request lightweight and faster. For now, let's add the field sales order type internal code. Later, I will show you how to find all the available fields in this API. Now, I'm adding a filter condition. Here, I'm filtering the records where the sales order equals sales order ID entered by the user. Next, I am calling execute function. This is where the actual API call happens. This SDK dest object contains the destination details. In our case, the SAP API Hub sandbox URL and our API key for authentication. So when this line runs, it sends the request to the S/4HANA Cloud Sandbox system and brings back the data. Finally, we have a catch block at the end to handle any errors. If something goes wrong, maybe the API key is invalid or the sales order doesn't exist. It logs the root cause and the response body to the console. So in short, this entire block builds our OData query, applies the filter, fetches the exact data we need from S/4HANA, and safely handles error. Let's test this code by sending a request from the test.http file. Pass the sales order number as 2 here. Before sending the request, make sure that you have added some breakpoints to debug the code. Click on the play button on the top right to start our CAPM server along with debugging. Here in the debugging button set, if you click on the first button, it will execute till each breakpoint we have added, and the second button will execute the code line by line. As you can see, the API is executing and returning something which got stored in the sales order data array, but not in readable form. We have to deserialize this to use the fetched data. For that, I am creating an empty array called sales order array. This will store the final cleaned up data that we will return from our cap function. Then check if sales order data.length not equal to 0. That means I only want to process the data if the API actually returns something, because if sales order doesn't exist, there is no point in looping. Now comes the important part, the entity serializer. So inside the loop, I'm calling the entity serializer.serialize entity function. with sales order data as the first parameter and sales order item API as the second parameter. It takes the raw data returned from the API and converts it into a proper JavaScript object that matches the OData model defined by the generated client. Basically, when we consume API using the SAP Cloud SDK, the data that comes back can have special types, for example, structured objects, custom formats, or even EDM types from OData. The entity serializer helps us serialize that data into a clean, plain JavaScript structure that's easy to work with. This serializer code will be always like this for every APIs in S4HANA. So we only need to change the parameters in this code and the APIs used. After serialization, I am pushing each record into the sales order array. So by the end of the loop, the array contains all the sales order item details in clean and structured format. Finally, I return this array, which will be passed back to our Fiori frontend and displayed to the user. In the top, we have to import the item serializer function from the SAP Cloud SDK. Now let's change our existing field from sales order type internal code to something else. For this, find the sales order item API file in the generated folder and use any field name from the file. Now restart the server and test the function. You can see the data fetched from S4 as the response for this GET request. You can add any number of fields in the select query. Make sure to restart the server whenever you are making any change. I am adding one more field, requested quantity unit, in the select query. Alright, now let's switch to the front-end side. This is where the user actually interacts with our application to fetch sales order details from S4HANA. Find a button to trigger a function which sends the fetched request to the backend. For ease, let's use any existing button we have in our Fiori app. In the header section, we have a diamond button. I will use this button to trigger the function. Here we need to add the press attribute along with the Fiori function name. I will name the function as onFetchSalesOrderData. After defining the function call, let's add the function definition in our existing controller. It's a good habit to keep error handling everywhere. Then create a symbol label and an input field using standard SAP UI5 controls. The label asks the user to enter a sales order number and the input box is where they will type it in. Now define a variable that gets the default OData model that is connected to our current Fiori view. Here I am creating a dialog with a title sales order, and inside the dialog I am adding both the label and input field we just created. Then define a submit button. When the user clicks submit, this function gets triggered. Inside it, I grab the value the user entered, that is sales order ID. We have to add some more functions apart from submit trigger. Add a end button trigger for cancelling the pop-up and a after close trigger to destroy the pop-up after closing it. There are some errors in the written code. We have to fix that before testing. Like change the spelling of label 4, then open the dialog box, change the close function to destroy function, make the close function to lowercase. Now it's time to test our dialog box and its button functionalities. As you can see that every button is working successfully. Next, we need to grab the value user entered. Then call the cap function. Remember, we defined readInvoiceNumber inside our cat-service.cds file. So here I am binding that function using omodel.bindContext along with the function name in the CAPM. Then I pass sales order ID as parameter using set parameter. Make sure to pass the ID as the same variable name used in our CAPM service. After that, I execute the function call using await o_function.execute. This line actually triggers a call from our Fiori app to CAP backend and then out to the S/4HANA API via the SDK. Once the execution completes, we get the response back in sales order details. Let's log the data in the console first. If we get the response, then we will format the response data and show it to the user. Let's test our current code in the Fiori application. Give any sales order number and check the console. If we check in the Network's Response tab, we can see that the fetch request is returning some data for this particular sales order. Finally, inside this block, I am creating a variable called formatted text. Here I am simply combining all the key fields from the response like sales order item, requested quantity and requested quantity unit into a readable string format. I am adding line breaks, that is /n, so that each piece of information appears on a new line when shown in the message box. Use a messagebox.information function, which is a built-in SAP UI5 pop-up that displays the data in a clean dialog style box. I am passing the formatted text as the content and setting the title as sales order details. Let's try this out with one value from the response. If working, we can add more. Since it is giving the response as per the input value, we can add the rest of the response in this information pop-up. And there we go. A pop-up appears showing the details. The sales order number, the sales order item, the requested quantity and the requested quantity unit all coming live from API Sandbox. So everything looks great. But if needed, you can add a margin to the input box to make it look more good. And that's it for today's video. We have successfully connected our SAP CAPM and Fiori application with S/4HANA Cloud using the SAP Cloud SDK and fetched real sales order data using an external API. This is a huge step forward. You have now learned how to extend your CAPM projects with the real-world API integrations. I'll be pushing this complete code to my GitHub repository and the link will be available in the video description below. If you found this video helpful, make sure to like, subscribe and hit the bell icon to stay updated for upcoming videos in the SAP CAPM series. Thanks for watching and see you in part 14 where we will continue enhancing this application further.